Basically a DTrace script that said every time I had a VM info event, I'm going to collect a bunch of data that I'm going to count aggregate on, and then I'm going to print everything I'm aggregating on. So I see the exec is the name of the process, the function and the name are the two components of the probe name, and the count is the number of times it happened. So for example, I could see that I had a process called Oracle that generated a lot of address space faults. Big surprise, I'm running Oracle. That happened 16,000 times. I had a program called M2 Loader that did a lot, 7,000 times, and so on and so on. And then this output is coming out once a second. So with the relatively simple DTrace script, I can, one of the things I like to describe DTrace as is it's a connect the dots technology. DTrace gives you the ability to connect the dots. It gives you the ability to look at a system metric or a system statistic and tie it back to the process or thread, if you like, the specific components of your workload that are generating that activity, right? Previously, if you ran VMstat, for example, on a Solaris machine and you saw you were getting a lot of page ins and page outs, you were getting a lot of memory activity, what's the first thing you want to know? Who's generating those page ins and page outs? Well, without DTrace, that's a really, really, really hard question to answer. With DTrace now, you can connect the dots. You can correlate that system statistic to the process that's causing that activity and get the question answered very, very easily. I'm not going to do this. Page faults, all right? We all know what page faults are. You see them with VMstat. A page fault means that a process made a reference to a location in memory, and that memory location wasn't mapped for it. So the kernel, so it caused the system to go into a trap handler, and the trap handler had to say, I've got to set up this memory location for this process. That's at a high level what a page fault is. I see a lot of page faults in my VM statistics. At a system level, I need to connect the dots. Who's causing those page faults? Oh, I can see Java did it most of the time, Oracle did it a lot, and then I'll list based on the count aggregation. So again, I can connect the dots and figure out and see who's actually doing what. I'm going to skip that. I.O., I know I'm out of time. It's 8 o'clock. Give me one more minute. Because this is kind of cool, I think. Let me see if I can find one over. Yeah. Well, I guess you're going to have to go take a look at the slides, but so this is a DTrace script that actually it decomposes all the I/O at a system call level on a per file system basis. We actually saw an example of this before, so I could see how much of my I/O is network versus NFS versus ZFS versus, so I can, like, at a high level categorize my I/O. I can see which functions are being called. I can look at low-level disk I/O. So here's an example of a DTrace script where I have lots of probes. I have the I/O start probe, and I have the same probe more than once. You can do that too, right? There's no reason you can't. You can have multiple probes. You can have a probe with the same name, different predicates, right? Here I'm using the I/O probe to say, I want to track reads, and I want to track writes, and I want to print data out once a second. And that's all I have time to tell you about that particular script. But here it is. I run disk I/O, and I can see I'm doing, I'm looking at a particular process, Java. This is kind of cool for you shell programmers and C programmers and awk programmers. DTrace gives you the ability to write a D script where you can pass a command line arguments of your own choosing. You have, just like in shell, you have $1, $2, $3. You have that in the D language too. So you can write generic DTrace scripts, and here I'm using a script that says, a predicate that says if exec name equals $1. That means I want to pass the name of the executable on the command line. And what I did is I said, I want to run this DTrace script, and I only want to look at processes named Java. And I can see all my Java processes did 6,000 reads per second, 9,000 writes per second, this many read bytes, this many write bytes. I mean, it's a beautiful thing. With a relatively simple DTrace script, I'm able to get a lot of very precise performance information about a program running on my machine, whether it's Java, whether it's Oracle, whether it's homebrew code, it doesn't matter, and I'm doing it all on uninstrumented code. I didn't have to get a modified piece of the software from whoever it is that owns the software. I'm just using DTrace to take a look and figure out what it's doing. So I am like grossly out of time. So I apologize for having more slides than I had time. I apologize that we were all over the map, and I thank you for indulging me.
Thanks very much, Jim. There's a massive amount of content there. How many slides have you got left? How long can you keep going for?
No, I've been doing this for 20 years.
I saw a big scroll bar.
Oh no, look, summary, we're done. Any questions? Actually, that's not bad for me. I usually have like 3x more than I have time to do, but yeah, but I think these are downloadable for everybody.
We'll put them on the website,
Okay.
Yeah, we'll get them on tonight or tomorrow or something, so
Okay.
yeah, no problem at all. So if anybody has any questions, now may be a good time, or if you want to get Jim after, with some food, that'd be great too. Otherwise, next month we've got a talk from Alistair about Open Indiana, I think. Some of you may have heard of Open Indiana. If anybody wants to volunteer to give a talk, that'd be fantastic too. Email us and
I'd love to come back and give one of these that actually makes sense.
yeah, part 2, or part 2, part 3, part 4, I think.
Okay.
Yeah, that'd be fantastic too. So great. Well, thanks so much, Jim. So,
Thank you.
okay.